What we're going to have a little look at now is the different components that make up a computer. Firstly, we've got the CPU. Now, the CPU is the central processing unit or processor, and it does all the thinking, all the fetching the different bits of data, working out what to do, all the mathematical calculations, everything like that. It's got three main areas. One is clock speed, and that's how fast it works. So you've probably heard about gigahertz before. 1 hertz is 1 piece of information per second. So, 1 calculation per second. Kilohertz, 1 kilohertz is 1,000. Megahertz is 1,000,000. And gigahertz is 1,000,000,000 calculations per second. That's how many different calculations your computer manages to do. Cache memory is very expensive, very small memory that's actually stored on the processor or very close by. And that's got only a tiny amount of data and it's really, really fast. It's called static RAM, and what it does is if your processor needs something when it's doing a calculation or trying to work out something for a program or a game, it will go there first to check to see if it's there because it's really, really fast rather than checking the RAM. Further to that, we've also got cores, single, dual and multi-core. Now these are multiple processors on one chip. There's another video about single, dual and multi-core, so I won't go too much into that. But each of the cores has its own cache memory and can connect to any of the rest of the components. Next we have RAM. This is your traditional RAM. So you normally have 2, 4, 6, 8 gigabytes of RAM, possibly 16. This is the second fastest type of memory in the computer, but this RAM is called dynamic RAM. Now, all RAM is temporary storage. So what will happen is when you lose power, everything that's in the RAM will disappear. So nothing's ever stored there permanently. That's on your hard drive. Now, dynamic RAM, it can be searched in any order. That's why it's dynamic. It is fast. It's the next stage beyond cache, and it's in between cache and hard disk drive. What it will do is your computer will try and work out what you're going to use next, and it will store it in your RAM. It's not always possible to do this. It might have to get some information from your hard drive to be able to do it. But that's what RAM is for. It's a temporary, short, but fast type of memory. Next we've got ROM. Now ROM you don't really have to deal with all that much, but you may have heard of it with CD-ROM. Now CD-ROM is a disk that you can't write to. It's already been written on. It's exactly the same with ROM in your computer. It's read-only memory, you can't write it, and it's pre-programmed. So there's something called a BIOS inside your computer. When you first switch a computer on, it doesn't know what to do. What it does is it's got a little chip called the BIOS, and that has got all the instructions, so the BIOS will tell it what operating system to boot, or whether to boot from a CD or a USB drive or something like that. And that's what the BIOS is. So ROM is pre-programmed, often done by the manufacturer, but it's in there and it tells the computer what to do. Now the GPU deals with graphical operations. So what that means is everything that goes out to your screen will be run through the graphics card. It's a lot faster at doing this than your processor would be, and it takes some of the strain off of it, especially if you're doing 3D design, video editing, computer games, things like that. And it also provides you your outputs. So in the image you can see DVI output, but you also have HDMI, VGA. There are component outputs on some of them. You can have TV in on some old ones. So that's what the graphics card is for. And there are two main types of storage as well that you get inside a computer. You've got your HDD, which is your traditional hard disk drive, and it's got lots of little tapes, magnetic discs, and a playhead runs up and down, reading the data, writing on it very, very quickly. And it's quite fast. It's very cheap relative to almost every other type of data storage, but they're quite big. So you can't really tell from that picture, but it's the size of a decent sized paperback book. And actually, if you knock it or run a magnet over it, you'll lose the data. it can be corrupted. An SSD, on the other hand, is actually like your ROM, but it can be erased. So it's kind of a step beyond it. It's actually the same as a flash drive that you would have in a USB stick or an SD card or something like that. It's extremely fast. It is not a huge amount slower than RAM. It's portable and it's reliable, but it is more expensive. And actually, it's not the most durable. There's only a limited amount of times you can erase and write onto it, though that is improving over time. Obviously, I've mentioned SSD. It was mainly a secondary storage device, like flash drives. It's very, very similar. So they're quite expensive. You'll have seen a 64GB card is very expensive, especially when you compare it to a hard drive. Most of the time you get 8 16GB cards, and that will be what most people get because of the price. There's cloud storage as well. Obviously in school and with Google there is a lot of free cloud storage, but cloud storage is very expensive if you don't get it free. Now that sounds very strange, but it can be very expensive and it can be slow and completely dependent on your internet connection. No internet connection, no cloud storage. Finally, we have optical drives, CD, DVD and Blu-ray. CDs can have about 700 megabytes of data. A DVD, 4.7, although you can get dual layer and dual sided DVDs, not so much anymore. And then you've got Blu-rays, which can be up to 128 gigabytes. Obviously the image shows larger ones, but you'll tend to find 128 gigabytes is the largest. A lot of computers are starting to forego dedicated CD, DVD, Blu-ray drives. You still find them in some, but it's starting to be phased out, especially with iPads clearly. Some of the MacBooks, the Surfaces from Microsoft is not seen as quite as important. Things to bear in mind, it's very slow reading and writing from that. Finally, we've got a couple of things here which are essential to computers working, but you don't normally think about as components. So you've got the PSU, the power supply unit. It's needed to power every component in the computer. If you don't have it, you're not going to get any power. Nothing's going to turn on. And it's got lots of cables that run from the back, lots of buses that connect and actually get data backwards and forwards to all of the different parts. So if you put a graphics card in, it needs power. If you've put in a new hard drive, it needs power. So it's really important that you've got the power supply unit that will suit what you need. Lastly, the motherboard. Now it's quite an important component here, and you'll see it's got lots of slots and areas where you can put different things in. You've got space for your processor, you've got space for RAM, you've got, it's harder to see on here, but you've got all sorts of slots where connectors will go for your hard drive and for your optical drive. This should take RAM as well. There's lots and lots of things on there. It also provides basic input and output ports. So you'll see at the far end over here, these are some ports. It's got a USB drive there. It's got graphics ports, USB ports. So although you do get outputs with your graphics card, if you didn't have a dedicated graphics card, you'd have an integrated one that was based on the motherboard and get your outputs from that. One thing that's less of a component but very essential inside a computer is cooling. Now, obviously, with those millions of calculations a second, your computer and your processor gets very hot. So you have things like heat sinks, which is lots and lots of pieces of metal. This will allow the heat to dissipate because it's a large surface area. You've got fans that blow cool air. Obviously, if these get blocked, the computer will overheat, it could damage components. You can get water cooling and all sorts of things like that on high-end computers. Cooling is very important. And this is an example computer with lots of components. You've got your hard drive down there, graphics card, a fan and a heat sink over the top of the processor that you can't see, a fan in the side there. You've got RAM in those two slots there, power supply unit, and optical drives up here. So that is pretty much everything to do with components in a computer.